Okay, so today we're going to be talking about how to construct parallelograms. In general, it's quadrilateral, but if we're going to give it a definition, there's 3 or 4 ways that we can describe it. So we can say it's a quadrilateral with 2 sets of parallel lines. Another way to say it is that it's 2 sets of opposite congruent sides, meaning that these 2 sets are going to be equal to each other. And then these 2 are equal to each other in length. Another way is controlling 1 set of the parallel and congruent sides. And then the last one is bisecting angles and diagonals, but that one they will be discussing on another day. So I'm going to go ahead and share my screen. Okay, so the first step of constructing a parallelogram is to get a segment and place it anywhere you want and whatever length you want. And then you're going to make a second segment starting at A again, and then stop it wherever you want again. You can move these points around freely, and they can be whatever length you want them to be. So then next you're going to use the compass tool. And there's 2 ways that you can do this. You can either click point A to point C, or you can just click the center line that's connecting the 2, and you're going to get this circle. Now this circle we can move over to B, and the radius is going to be the same all the way around, and it's the same radius as A to C. So we're going to get another segment and click on point B, and then just drag it to the outside of the circle. And now point D can move wherever it wants to along that radius. Then you're going to go back and get the compass tool again, and this time you're going to press on the line AB, or you can drag it from A to B or B to A. I'm going to take that circle and press it onto point C. So now it's stuck, and when you move point C, the circle moves with it. So the next step is you're going to move around point D, and as you can see, there's 2 intersections. There's one down here, and then there's one up here. For now, we're just going to ignore the lower one because it gives us a parallelogram that we, for this class, are going to reject as of now. So what we're going to do is, knowing that BD has the same radius no matter where you put it, we're going to place a point onto the intersection of circle C and circle B, the top point, and boom, you have another point. So now we're just going to use polygon tool from C to E to B to A to C, and we have our parallelogram. I'm just going to make these circle stashes so it's easier to see. And now we can freely move around the points, and the lines CE and AB stay parallel and congruent with another, and then CA and EB stay congruent and parallel with one another. If you want to prove this or are wondering how I know that they are parallel to one another, we can use the distance measurement, and we can measure CE, just click on that line, and then measure AB, and that's 4.9, so those are equal. And then CA and EB, so we know that those 2 lines are the same length. And I am going to color code those lines to be blue, and then the other ones to be red, just so you can see it more clearly if it will let me. So now if you move point C, we see that CA and EB stretch and they're always the same length, parallel to each other. Same if we move point A. And same if we move point B. Only point that we're not going to be able to move is point E, and that's because it is stuck or constrained to the two circles of C and B. So yeah, that is how you construct a parallelogram.